In this video, I'll demonstrate a few different things using Factorial ANOVA. First, I'm going to run the Factorial ANOVA in SPSS. I'm going to show the interaction effect for the Factorial ANOVA. And I'll demonstrate how to put those results into an APA-style table. Sometimes creating those APA-style tables is tricky. So using the data that I have on the board here, I'm going to demonstrate how to take those individual scores that you see and turn them into first a table showing the means and standard deviations, and then a second table showing the results of the Factorial ANOVA. Now, for these hypothetical data, what I have set up is a 2x3 Factorial ANOVA where gender is split with males and females. We have an equal number of students in each group, which is a luxury that we have because it's fake data. Grade is the grade of the school that the students are in, 4th grade, 5th grade, 6th grade. And you can see that I've got 10 scores in each group here, each cell of the design. Because it's a 2x3 Factorial ANOVA, you can imagine that the number of cells would be 2 times 3. And that the math there actually works perfectly. And so we have a resulting pattern of 6 different cells. We're going to want to map out all these cells in our APA-style table. Before we do that, though, we have to analyze the data in SPSS. And I've taken the liberty of doing this beforehand. So I've got everything set up. If we toggle between variable view, or rather variable labels, you can see that the number system that I have set up is 0 for male and 1 for female. And the way that you do that is if you toggle over to variable view down here. For gender, we just enter the numbers 0 for male and 1 for female. Now certainly if you were doing this as a real research project, what you'd want to do is give the students the opportunity to pick non-binary or some other option like that that more accurately represents the full range of responses. In my experience, and I've had a fair amount of experience with this, when you have a fairly large group of students, grade school students, say if you have 100 students, you might get 1 or 2 choosing the non-binary option. Those percentages in terms of the ratio of students choosing such an option have been going up over the years. Say 20 years ago, very few, if any, students would have picked that option, but now you'll start to see that there are more, perhaps even up to 3 or even 4%. The problem that we have with a small data set like this is that if we have only one student choosing a non-binary option, there's no way to actually analyze that data. So if we had another row here, and we certainly could if we wanted to, if we had another row underneath for non-binary, you might get no scores here, no scores here, maybe only 1 score here. So I haven't included it, but it's not because I'm trying to exclude them. So let me delete this. These cells, and I'll just go like that. Okay, so the dependent variable are the actual raw scores that we see here. And those raw scores in this hypothetical, they represent anxiety. So we're measuring students' level of anxiety. And I've set this up so that these scores are on the same scale as a t-score, where the mean would be 50 and a standard deviation of 10. I actually generated these numbers using a Gaussian random number generator, which simulates the normal distribution as it randomly selects the data points. And then I adjusted them somewhat to show the pattern that I wanted to demonstrate for today's lecture. So we've got 10 scores in each one of these groups. There are a total of 60 students. And in SPSS, let me go back here, you can see that I've got my coding strategy set up so that 0 is male, 1 is female. Just by tradition in my life, I've always coded gender in that manner so that I never forget which one is 0 and which one is 1. And then if we go back over to data view and toggle the value labels, then we get to see the names instead of the numbers for this single variable that's been named in this manner. You see the grade, it makes no sense to give that a name because it's 4th grade, 5th grade, and 6th grade. And anxiety, that's a raw score, so it doesn't need a value here. But for gender, we do need a value so that we know when we look at the output which one is which. And then in terms of setting up the factorial ANOVA, what you see is that the first 30 rows here are all male, and then the second set of 30 scores are all female. And the reason why that happens is because what I'm doing is I'm entering all of these 30 scores first, and then I'm entering all of these 30 scores. And in SPSS, what you want to do to run a factorial ANOVA is you want to set up your first independent variable in one column, and then your second independent variable, which in this case is grade, as a second column. And we need to have this crosshatch pattern where you have 4, 5, 6, like this, matching with the value of 0 for gender, rather. And down here, you'll see that the 4s repeat and the 5s repeat. This is what I'm talking about with the crosshatch pattern. That will inform SPSS who's in which group in the 2x3 factorial design. With the 6 different groups, this becomes very important. And now I can put my 2 different independent variables into the analysis plan. So in order to analyze the data, what I'm going to do is I'm going to go to General Linear Model, Univariate, and you can see that I've already got it set up. Let me reset it so that I can start fresh. I'll take both of my independent variables and put them here under fixed factors. I'll take anxiety and put it under dependent variable. And let's just run that in terms of a vanilla output without any of the options and see what we get. And down here you can see the results. Here's the F-test. And the ones that we're interested in are gender, grade, and the gender by grade interaction. The rest of this output table we don't care about. These are the 3 different parts that are important, the 2 different independent variables and their interaction effect. And we'll also need the degrees of freedom for each one of these, and the error degrees of freedom, which if we're using a formula, that would be your DF within. These ones up top are the DF between. Well, actually that's the full model, DF between. And then this would be the degrees of freedom for your gender main effect, and the 2 here is the degrees of freedom for your grade main effect, and then the 2 here is the degrees of freedom for the interaction of the 2. We'll also need to report the F results, and you can see that it's rounded off at the 3rd decimal point. When we put it into the table, we want to turn it into we want to change that so that it's at the 2nd decimal point. And I've already gone ahead and done that in my Word document, so I don't need to change that in the output. I never copy and paste these sets of results because they give you too much information. We don't need half of this table. In addition to the degrees of freedom for the 2 main effects in interaction, the degrees of freedom are here, and we'll need the denominator degrees of freedom. We'll need to report that for each one, and I'll show you how to do that. We'll also need the F-test result. You can see I've got the 3 different relevant F-tests circled here. And then we'll also need the p-values, which are right here, 0.03, 0.000, 0.032. Okay, but that's not everything that we need, because we also want to report the effect size. And the effect size is, in SPSS, it's reported as eta squared. And so that's what we're going to report here. And in order to get eta squared, what we do is we go back to the options in general linear model univariate. And over here in the options button, click that and you can see that we have a whole bunch of different options. I'm going to go ahead and click descriptive statistics because I want to get the means and standard deviations for each group. And I'm going to get the estimate of the effect size here. The other parts of this I'm not going to be concerned with right now. I'm going to hit continue and OK. And now you can see that I've got this table that shows me the information for the means and standard deviations for each group. For males who are in the 4th grade, the mean is 51.80. I'm going to round that off at the 2nd decimal point when I report it. The mean is 51.80, and the standard deviation here would be 4.69. The extended decimal points here have to round up in order to get rid of them. So the standard deviation for males in the 4th grade would be 4.69. You wouldn't report this one down here, the total, unless you were interested in the main effect comparison for males versus females. But what I want is the cell by cell means and standard deviations. So the parts of the table that I'd be reporting would be this one, this one, this one, this one, this and this. And then the same thing for the females down here, this one and this one, this one and this one, this one and this one. And that's it. I don't do this part down here. Those are what we could call the marginal means, but we don't need that. The part that we need is highlighted in the male and female sections, and you can see the sample size here. I'm not going to report the individual sample size because in my APA style table that'll take up too much space. What I'll do is I'll put a note underneath telling the reader that there's a total of 60 participants with 10 in each group. Okay, then scrolling down, we can see that the ANOVA summary table is the same as it was before, except that now it has partial eta squared. And we'll need to report these parts right here, 0.084, 0.259, 0.120. Normally I round these things off at the 2nd decimal point, but for partial eta squared, because it's an effect size which arguably is the most important part of the output, I'm going to report that at the 3rd decimal point because small values for an effect size can have an important meaning. So keep that in mind. You don't have to do that, I think. You could also round the effect size off at the 2nd decimal point and be considered correct. But you'll see in a lot of publications that people do take that to the 3rd decimal point. Sometimes you'll see that they report also the total model R squared, which is down here, telling us that the 2 different independent variables are explaining about 37% of the variance of the outcome. But this is not a regression that we're doing here. This is, I know that they're related, but what we're doing is we're just looking at the main effects and the interaction. Now, in this particular situation, we have the gender by grade interaction effect showing up as significant with p less than 0.05. And when you have a significant interaction, what you really need to do is look at the graphic for the output here. What I want to do is I want to create a line chart in order to see what that interaction looks like. I'm not going to do simple effects test in this video. I do that elsewhere, but we do need to take a look at the line graph. So I'm going to go back here one more time to the general linear model, univariate, and you can see that there's an option here for plots. I'm going to click that, and I'm going to take whichever of these variables I want to be in the columns and put that into horizontal axis, and gender goes into separate lines. I want one line for male and one line for female. Click Add, and I'll just use the default settings here for the line chart. I don't think I need error bars, but you know, why not? We can take a look at that, and if it gets too messy, we can take those out and run it again. So let's hit continue and OK, and now we get all the same output, plus we get the line chart. And I don't really like these error bars here because they're really taking up a lot of the visual information. So, and this is a matter of aesthetics. With publications, sometimes you might have a reviewer of your manuscript asking you to put those error bars in. Some people do them, some people don't. I think it is an important thing to do, but aesthetically, I don't really like the appearance here. Although it does tell us one very important thing, these error bars, it tells us that this confidence interval that's formed by this error bar is not overlapping with this confidence interval. In other words, when the kids hit the 6th grade, you see a separation of males and females in terms of their level of anxiety, and that's being represented here in the statistical results in the interaction effect. So this interaction effect, where the p is 0.032, is significant primarily because of this element right here, where we have these lines diverging in the 6th grade with girls having higher anxiety. And I know it's artificial data. I set it up intentionally like this because this reflects what's been going on in real life. But I'm going to, excuse me, I'm going to run it again without the error bars. So let's do it one more time. And let's go to plots. I'm going to take off the error bars just because they're taking up too much visual information in my chart. And also, you know, when we look at the raw data, you can see that some of the scores go down into the 40s. I don't think there are any going down into the 30s, but certainly the mid to low 40s are possible, and they could go up as high as the high 60s, even 71. So what I'm going to do in my figure is I'm going to change the scale on the y-axis. The y-axis represents the anxiety on average that the students have in each of those different grades, broken down by male and female. Double click that chart, single click the y-axis, then double click that number. You get this pop-up, and go to scale. I want the minimum to be 40. That's arbitrary. T-scores can go below 40, but I think 40 is a good number here. And let's put the high score up to, I don't know, let's try 80 and see what that looks like. The point is here, SPSS artificially makes your figures look more important than they are, and it's an annoying feature, I find it to be annoying anyway, about SPSS, because it sort of forces us to go in and make it a little bit more realistic by changing the increments of change on the y-axis. And I think here that 40 and 80 might be reasonable, so let's take a look at that. Now you can see what it looks like after I've changed the scaling. And that certainly is more reflective of you know, a pattern that you might see in a publication. I think aesthetically it looks better, maybe even with the top of the y-axis ending at 70. Let's try it like that. So again, you double click the figure, single click any of the numbers on the y-axis, and then double click it, and you get the pop-up where you can change the scaling. That's pretty good. I like the aesthetically pleasing way that this figure looks, and so I'm going to keep this one. I think that's pretty good. And you can see that with grade on the x-axis, it's increasing from 4th grade to 5th grade to 6th grade. And you can see the pattern of change for the students, that the males and females are pretty much the same. No significant difference at the 4th grade. They're virtually identical at the 5th grade. And then at this particular hypothetical school, something happens at the 6th grade that makes and it could be something about the school, or it could be something developmental about the kids. We don't know. But there's something that's making the female students' anxiety scores go way up. And that is the interaction effect at work. Okay, so one other thing to show with a bar graph here. It's called a figure, even though it's a graph. In APA style, we would call it a figure. If you wanted to, and I think that you should change the legend on the side here. Estimated marginal means has no meaning for us in terms of helping us understand what's going on with the graph itself. So with the yellow highlighting around that legend, what I'm going to do is I'm going to change the text so we can see, let's say, anxiety level instead of estimated marginal means. You can, of course, change it to anything that makes sense based on the set of data that you're working on. And I don't particularly like this one either. So I'm going to change this. Let's call this students' anxiety level by grade. Now you can, if you wanted to, copy and paste this just very simply like this and put it into a document as simple as that. You could also resize it. It's a JPEG at this point, which is convenient. You can resize it so that it looks more aesthetically pleasing in terms of how much space it takes up on the page. If you wanted to make this APA style, of course, then what you need to do is call it Figure 1. Figure 1 has to be in bold, and then give it a title. I know it's already sort of got a title over here, a student's anxiety level by grade, but you'd also have to have a title. Let's call it student's level of anxiety by gender and grade. Now, in order to be APA style, that has to be in italics. Also, you need capitalization. You can see that a couple of the words here are not capitalized. APA style states that you have to capitalize in this way. Now that is APA style for a figure. Okay, what about creating a table for the means and standard deviations? In SPSS, I've got the means and standard deviations here. What I like to do is just copy that and put it into a Word document. And you can see I've got this Word document here. But I'm not going to report it like this because it's too messy. It looks terrible. What I want to do is I want to just print that out. And I already have a printout. And that makes it easier for me to enter the data into an APA style table. So I've already done that. I've created my APA style table. Notice that I've got the note down here with the sample size defining the information There's a specific way in which notes have to be written to match APA format. The word note is in italics, period, and then the rest of it is a regular sentence. Remember that whenever you have a statistical notation that is an English letter, like mean or standard deviation or n, those have to be in italics. Words like gender or school grade do not get italics, but any statistical notation does. So how did I set this up? I'm going to put all of my borders back in so that we can see how that worked. I go to Table Design, Borders, and click All. So when I set up one of these tables in order to make an APA style table, all that I do first is on a piece of scratch paper, I draw it so that I know how many columns and rows I need. There's no real rule for how to do this. APA gives guidance, and the guidance you can see right here. This is from the 7th edition of APA Publication Manual. Now, they've got a few different examples of ways to do different types of tables, and for this one you can see this is a sample analysis variance table, and this is a one-way ANOVA, but ours is a factorial ANOVA, so this isn't going to work because you can see that there's no way to see the interaction effect. What we have are several different one-way ANOVAs. We have 1, 2, 3, 4, 5 separate one-way ANOVAs in this table, and you can see eta squared over here. That's your effect size, Greek letter eta. Okay, but this isn't going to work for us. So what we need to do is we need to figure out a way to create a table using a factorial ANOVA strategy. And here's one that has a two-way ANOVA, and it incorporates the means and standard deviations into a single table. I don't know. This would be considered okay. I mean, this is definitely correct. It's in the APA Publication Manual. Essentially what they've done is they've taken two different tables and put them together into one. So if we just focus on this top part right here, from here up, psychological strain, you can see that it is a 2x3 Factorial ANOVA, so this part matches what we've put together. You have SMT versus control, that's one independent variable, and then we've got time, 1, 2, 3. So presumably this is a mixed ANOVA where you have a within subjects part, that's time, and a between subjects part, that's SMT versus control. So that's a little bit different than what we have, but that's similar enough. You can see that they have the means and standard deviations arrayed here in this section. And then over here, they've got the main effect for one variable, the main effect for time, and then the group, G stands for group by time interaction effect. And that's a nice space saver. It saves a lot of space when you do it this way. Just focusing on that top part, we've got a 2x3 Factorial ANOVA with the means and standard deviations and the two different independent variable main effects and the interaction of those two. But I find these difficult to work with. Either way would be considered okay. You could do a second table that has the ANOVA results, and that's what I've done for this example that I put together. It would be okay like this, and I think one of my previous videos shows you how to do that table following this pattern. But and either way would be okay, would be considered correct. But you can see that what I've done here is two different tables, and it just makes it easier to read. Also, if we lined up the tables side by side in a single table, if we combine these two, because of the way that I put a grade up here, 4, 5, 6, it would make the table too long for the page. And so I think that's sufficient justification for us to have two different tables instead of one. So anyway, back to the table construction. What we want to do is we want to count how many columns and rows we need. And in order to do this, I simply wrote down on a piece of paper, counted, what I planned to do, and then I created it. This is 1 column, 2 columns, 3 columns, 4 columns, 5, 6, 7. You need 1 column for the gender independent variable, and then we've got 6 different columns that form the means and standard deviations of the 3 school grades. This is called a decked header setting. This is a spanner because it spans across this range, and I'll show you how to set this up. So if we, how many rows do we need? We need 1, 2, 3, 4, 5 rows. So 5 rows and 7 columns. I'm going to just do the rudimentary elements of this. I'm not going to do the whole thing over again. But in terms of getting it started, I want a 5 by 7 table. So using this grid pattern in Word, insert table, and then just highlighting it like this, you can see that I've got the rudimentary elements for the table. In order to make it approximately right, now I don't follow any specific rule for the width of these rows, but you want it to be aesthetically pleasing. So what I've done is I've stretched out the bottom one, and then with the whole thing highlighted, right click on it and distribute the rows evenly. Now you can see that you've widened the spaces so that it simulates what it should look like if it was a double spaced table. The automatic table creation is really narrow. Those rows are really narrow. If I hit the back button, you can see it's just too narrow. It's going to look really congested. So the way to do this in proper APA style and have it come out looking like an APA style table is to stretch it out a little bit like that. And then what I need to do is I need to go to Layout, center everything, and when I do that, I'm going to use this button up here, this one right in the middle. That's in the Layout function group, like that. Now when I drop the information in here, it's going to be centered. The other thing that I want to show you how to do is how to create the decked headers up here. We've got these sections that don't have it doesn't have the same structure. So how do you do that? Highlight these two. That's going to be the 4th grade. With those highlighted, then merge the cells. Do the same thing one at a time for each grouping. Don't hit delete. Hit merge. And then you can insert the numbers like that. On top, for the decked header system, we're going to merge all of these together, and that's going to be grade. And then our variable gender goes over here. Male and female go down here. And you can see that there is a little bit of a difference here because of the centering. APA style states, and you can see this in any of these graphics, that the independent variables are flush against the left side. In other words, they're left justified. As you see here, these are left justified. And if you had variables within one of these conditions, then you can use the space key or indent it or create empty cells in order to have it work just right. I'm not going to do that for this one. I don't think we need to. All that I'm going to do is, well, we don't have anything to indent, so we don't need to. But they do need to be flush left. And so with those two, with male and female highlighted, I go up here to the alignment section, and I'll click that left center button right here. And you can see now that they're left justified. And again, this is APA style. The gender variable name stays centered. Then I could put mean and standard deviation, like that, that. And because these are statistical terms that have English letters symbolizing them, they have to be in italics. I go back to the home key in Word, hit the italics button, or use the shortcut for the hot button for italics. And then you can just drop in the data. And I'm not going to do that, typing it in. I'm just going to copy. I already did that, so I'm just going to copy and paste it. If you are doing copy and paste from one table to the other, this is the button that you want to use, overwrite cells. Okay, so it's looking pretty good, but what we don't have is the exact APA style for the invisible borders, and you have to do that in order for it to be APA style. So what I'm going to do is I'm going to highlight the entire table by clicking that little widget up here in the corner, in the top left corner. Go to table design, and different versions of Word will have these in slightly different positions. So your version of Word, if it's older or newer, or some off-label version of it, which some people have, it could be in a different location, but you should be able to find it. Go to no borders. I want to make all those borders disappear. The table is still there, but the borders are gone. And then with the table highlighted, I'm going to start putting them back in one at a time, the top and bottom, like that. So far so good. And then with this section highlighted down here, I'm going to use top border. And now you can see that we have a border separating the data results from the meaning of what we're looking at here, the means and standard deviations. Now we need the decked header, highlight the numbers for grade 4, 5, and 6. Those cells now, and you can see what the comparison is up here because these are identical tables at this point, 4, 5, and 6. With those cells highlighted, then go back up here, put in a top and bottom, or I guess, yeah, both top and bottom borders. Now we have grade is a spanner. It spans across all of this. We have our decked header, which is the line that goes across here, but not all the way across the table. You do not want it to go all the way across. In fact, it's a double-decked header, double-decker for this one. And that is correct APA style. Then you'd have to give it a Table 1 designation. Table 1 is in bold, means and standard deviation. That's my title for the table. Notice that it's in italics. And then the note tells the reader how many people are in each group. That saves us from having to put the sample size for each group in. If it's identical, you don't need it. You just put it in a note underneath. Okay, so that's how I created the APA style table for the descriptive statistics for the mean and standard deviation. And then I did the same thing with a different structure. I counted the number of columns and rows. I'm not going to show this one in full because I think you probably get the idea. It's just another table. This one doesn't have a decked header or anything. It's got 4 rows and 1, 2, 3, 4, 5 columns. You can see that I've got the F values for each of the different results, the main effect for gender, the main effect for grade, the gender by grade interaction effect. All of these are significant. I'm not going to go over how we interpret the significance in this video, just how we set up the results. Importantly, you want to have the degrees of freedom. The degrees of freedom are taken from the SPSS output. We match up the numerator degrees of freedom, in this case for gender, because we're dealing with two genders, male and female. The degrees of freedom would be 1. It's the number of comparisons for gender minus 1. So 2 minus 1. And then 54, we get that from the error degrees of freedom. That's DF within. So DF between for the entire study is up here at 5, but we're not reporting the one-way ANOVA results in this table. We're doing the main effects. So the 1 and 54 for gender, that's where it comes from. And then the other ones are 2 and 54. And we have 2 companion tables in APA style. One last thing, let me show you how to do this, the eta squared. And in SPSS, we know where to get that now. That's this partial eta squared. But you can see that SPSS spells it out. It's really eta squared. So we don't need to have the word partial. But I want to show you how to get that symbol. And let's see. I'm trying to get rid of the... You see what I've done is the superscript. So let me start it as if it's fresh. I need to go back here and center it. And I want to find the eta symbol. So where do we get that? Go to Insert, Symbol, and you can see all the different symbols that I've recently used. That's it right there. If you don't have it in your recently used symbols, because who would, right, if you're not doing this sort of stuff all the time, then click More Symbols, and you get this whole extensive system of choosing different symbols. And what we're looking for is the Greek and Coptic section. It's really Latin, but that's, you know, Greek is, I guess the origin is Latin. Greek is really what it is. And so that's the lowercase letter, Greek letter eta. You can see down here, it says Greek small letter eta. And if you don't know where it is, you know, you could just scroll through here until you find it. But go to the Greek section. Now, we have eta, but not the squared, so how do we get the squared on there? It's actually really simple. Go back to Home, and you can see this little x squared. If you hover your cursor above that, you can see it says superscript. That's what we're looking for, the superscript. Now when we type in anything, and you can see if we put in some letters, it's going to show up there really small, but it also gave us, it changed eta to H, which is really annoying. So let me try that again. Okay, I'm going to, actually it might be easier if we put the squared in first and then hit eta, because that way it won't change it from eta into the letter H. So I've got my squared in superscript. I take off superscript, go to Insert, Symbol, now hit eta. And now you can see that it is the appropriate form of text for eta squared. Because it's Greek, you do not italicize it. English letters get italicized if they're designating a statistical function. Greek letters do not. So we have 2 perfectly formed APA styles. I don't think we need a note underneath this one. But if there was something you wanted to explain, you can use that, the note ability down there. And the asterisk is, by convention, a designation that indicates the interaction of these two things, but I've also typed out the word interaction because I had enough space in here to do so. Okay, well, I hope you found that useful, and good luck with all of your computing. Take care.